Hello everyone! This description is intended for those who are not yet familiar with the architecture of microcontrollers with the MSP430 core. All microcontroller cores are similar in one way or another. Having studied one of them, you can quickly master all the rest, from simple to more complex. Microcontrollers differ in size, set of peripherals, pins, frequency and bit depth. And there are a great many of them. The smallest ones are no bigger than a transistor, and there are simply gigantic ones. There are many programming languages, compilers, and development environments written for all of them. You can write in high-level languages or the assembly language, and all this will be clear and transparent. But MSP430 is amazing at any level. For your tasks, you can choose a microcontroller of the appropriate size from SOIC8 to LQFP100. The MSP430 core is 16-bit, which allows you to solve many problems in almost any development. Some advanced developers might say that there are ARM microcontrollers, and they will be right. They really are. There are also electron microscopes, but this does not mean that you should hammer nails with them, and the use of 32-bit chips is not always justified. The main goal to start studying MSP430 is to dive into the world of microcontrollers with microscopic consumption. Imagine a microcontroller that can run on a single battery for several years. After all, it can programmatically control not only its own clock frequency, but also the consumption. For example, the CC430F5137 microcontroller, which the Titan boards are based on, can consume from 0.18 to 5.1 milliamperes. Impressive, isn't it? A huge advantage of MSP430 is the port mapping system. It allows you to programmatically switch port assignments at any time. There are many reasons for using this mechanism. The board topology interference, the need to use more UART/ADC/SPI/I2C than is available in the microcontroller, or it is just boring. What do you think about having a huge number of clock frequency sources? What else is there in MSP430? In fact, a lot of things. For example, in the CC430A5137, the basis of the Titan boards, there is a built-in real-time clock, a 128-bit encryption hardware system, a 32-bit multiplication subsystem, a 12-bit analog-to-digital converter, a comparator, UART/SPI/I2C/IRDA, and a built-in transceiver at frequencies from 300 to 928 MHz. When programming in C++, the process looks like a creation of a masterpiece by an artist. When programming in the assembly language, it is an invention of something fast and obedient. At the stage of designing schemes, it is the flight of imagination if you were an architect of the most modern skyscraper. Why is the MSP430 not as widespread as AVR or C51? Perhaps some are scared of the initial cost of the programmer debugger and the complexity of purchasing starter kits. What can you do using Titan boards? Build a wireless control system for electrical appliances, lighting, heating, water supply, etc. Build a wireless data collection system, temperature, humidity, light, vibration, noise, etc. Build your own wireless aircraft, a boat or a car. Organize a wireless data transfer system between computers. Build a wireless security system. Build a wireless staff notification system. Make tools for checking and controlling high-frequency circuits. What do you need to do this? Most of the Titan development boards contain a programmer debugger, which allows you to start learning and developing immediately with only a personal computer and your own imagination. The main differences between the MSP430 and other 16-bit chips are the ability to use the built-in real-time clock and the built-in transceiver at frequencies from 300 to 928 MHz. For a general demonstration of these features, we have put together a stand like this. At the bottom, the Titan I board acts as a time source. The firmware starts the internal clock, sets the alarm to 23 hours 59 minutes 0 seconds, displays the current time on the screen via the I2C interface, and transmits this information over the radio. At the top, the Titan board acts as a receiver of the date, time and alarm status from the radio. If the alarm is triggered, the buzzer will start and will be disabled when the alarm state ends. So we launch the stand. As you can see, the Titan family with the MSP430 core is a very powerful tool for developing a wide range of applications. In the next lesson, we will talk in detail about the possibilities of using the real-time clock and the built-in transceiver. Now you can buy the Titan development board on Platan, Ozon, eBay, and on PCB Electronics.